Good morning everyone. Today we will cover one of the important concepts of DSTL, that is discrete structure and theory of logic. The topic name is Boolean function and its simplification. Hi everyone, I am Chaitra Nasa, assistant professor from IT department, AKGEC college, and today we will cover this Boolean function in DSTL subject, right? So Boolean functions. What are the functions basically? Boolean functions. These are the functions which are made from the expression that are made up of the variable as well as from the Boolean operation. Now what are these expressions? These expressions are basically, for example, if we say any of the Boolean expression like E1 and E2, then they are made up by applying the operation on it. For example, we are having variable from xn to xn, then the expression are recursively defined on it using 0 and 1. So the Boolean expressions are E1 dot E2 or E1 plus E2. So each of the expression represent a Boolean function. The value of these functions are obtained by either substituting 0 or by the 1 for the variable in the expression. For example, let us consider we are having this Boolean function like f is defined on the three variable x, y and z, and that is equal to xy plus z. So if we need to make its truth table, we need to find the value of this Boolean function. How will we do? So as we are having the three variable here, right? So for the three variable, whenever you are having the number of variable, always the number of the inputs will be 2 raised to the power that variable. For example, here are three variable, so 2 raised to the power 3. So the total input variable will be 8. So now we are having x, y and z. So correspondingly, if you will gonna fill the truth table, we are having the 8 possible set of inputs. In the case of 8 possible set of inputs, what we will do? In the very first variable, we are having x, then we are having y, then we are having z. In the case of x, we are having then 4 0, 4 1s. Then in the case of y, we are having 0 0, 1 1, 0 0, 1 1. In the case of z, we are having 0 1, 0 1 combination like this. Now, what we need to calculate? We need to calculate the value of x, y. So, x, y is the dot operator of x and y, that is the AND operator. It means the outcome will be 1 only once x and y both are 1. If both are 1, then the value will be 1, otherwise it will be 0 for all the rest of the cases. Because in the case of AND, if any of the input is 0, the outcome will be 0 in that case. The second, we need to calculate z bar. Above it's mentioned z. So correct it with the z bar, right? So if we need to calculate the z bar, we are taking the complement of z. The complement, what it do? 1's complement is 0, 0 complement is 1. We will fill this column. Now what are our function? The function is xy plus z bar. If it is xy plus z bar, it means we need to do the OR operator on this. We are having these two expression, we need to perform the OR operation on this. This xy is the variable here, right? So if we need to perform the OR operation, in the OR, if any of the variable is having 1 or if any of the variable is having 0, the outcome will be 1 in that case, because 1 plus 0 is 1, 0 plus 1 is also 1. 1 plus 1 is also 1 in that case. In that case, you are having 0 only in one case when both of the variables are 0, right? So in this way, we will gonna calculate the value of this function here. Then there are some important concepts like what are the axioms here. So what are the axioms? These are the set of the logical expression which we will call axiom or the postulates of the Boolean algebra. An axiom is nothing more than the definition of the three operations like AND, OR, NOT. These are the three basic operations, like OR is denoted by the plus, AND is denoted by the dot, and NOT is either denoted by the exclamation or by the bar. So if we are having the value 0 and 1 and we are denoting the truth value false and true, so the 0 dot 0, as I am saying in the AND operation, if any of the input is 0, the outcome will be 0. So for 0 1 case, it is again 0. For 1 0 case, it is again 0. It is only 1 in the one case that both of the input variables are 1. Similarly, in the OR operation, what I say, if any of the input is having 1, then the possible outcome will be 1. It is having 0 only in the one case the both of the variables are having 0. Now the last one is NOT operator. NOT would say, if we are calculating the negation of the 0, it will be 1. If we are calculating the negation of the 1, it will be 0. Now let's continue with the axioms. In the axioms, it says there are number of the axioms. For example, the very first one is commutative law. Why we are studying these laws? Because these are further used in the simplification of our Boolean algebra. Whatever we having the Boolean function, we need to simplify them. For simplification, either we can use these laws or we can use the K-map strategy. So first one, we are having commutative law. The commutative law, it says whenever you are writing either A plus B, it will be equivalent to your B plus A. A dot B similarly equivalent to your B dot A. If you are doing the value through the value, if you are substituting the value for this variable 0, 1, then the outcome will be the same. In associative, it says the brackets we can move from one to another. Like if A plus B plus C, then I can pair the B plus C instead of A. Similarly, in the dot, if I am having A dot B within a pair multiplied with the C, then I can do the pairing of B and C as well. A dot B dot C. If we are calculating it with the 0, 1, again it will justify. Now the third one is distributive. What the distributive says, that outside variable will be distributed over the inner. For example, the first one is A dot B plus C. Here the A is equally distributed on B and C. So the outcome will be A dot B plus A dot C. Similarly, if there is A plus BC, then by the reverse of distributive, we can say here that here A plus B dot A plus C, because A is distributed over B dot C here, right? So below there is given the proof of this distribution, like we are having the right hand side A plus B dot A plus C. If we will open this expression, so A will get multiplied with the A dot C. Similarly, B will get multiplied with the B dot A plus B dot C, and we know whenever a variable is multiplied with the variable, A dot A will always be A. So by substituting it, we are getting A plus AC plus BA plus BC. Now if we are taking A as a common, we are getting in an inner bracket A plus C, and this is an axiom that if a variable is, any of the variable is added to the 1, then the value will always be 1. So if we will substitute it, we will get A plus AB plus BC. Now if we will again take A common, what we will get in the inner bracket, that is 1 plus B, it will again becomes 1, and then our final outcome will be A plus BC. That's how in the reverse distributive, what we say, if whenever you are having A plus BC, so the reverse of distributive will say it is A plus B dot A plus C. We can directly apply these axioms to prove the simplification. Like if you want to do the simplification, whenever we get this, we will simply write it A plus B dot A plus C. Or if reverse, if we are having A plus B dot A plus C, we will simply write it by the distributive law. We can write it down into A plus BC, right? Now continue to this. The fourth one is idempotent. We have used that in the previous one. What is idempotent says? Whenever a variable is having OR operator with itself, then it will be same. If it is having AND operator with itself, then it is having the same value A. So these are the discussed earlier as well, because we are need to cover up in the simplification. The last one is absorption. Now what is absorption? Like A plus A dot B, it is A. The B is get absorbed here. Now you can say how the A is basically B is getting absorbed here, because if I am taking A here common, what I will get in the inner bracket, that is 1 plus B. And you know, whenever a variable is added to the 1, then its value will be 1. So the final outcome will be 1. We will going to use it in the simplification process. So these are the some Boolean identities. Like if we are taking negation, already there is a negation. If we will do the double negation, then it will be the simple the variable. Idempotent, as we earlier studied, x plus x will be x, x dot x will again x. Identity says that if we are adding 0 to a variable, then we are getting the same variable. If we are doing the product of a variable with a 1, then we are again having the same variable. The identity is maintained here. The x will always remain x in that case. Then domination. What is the domination here? The domination is just reverse here. Now here we are not doing the dot product with the 1, we are doing OR basically, like x or 1. So the x plus 1. And what I say, if we are adding any of the variable to the 1, the final outcome will be 1. Now if we are doing dot operator with the x, we are having 0 here. Commutative, as we studied earlier, that the x plus y will equal to y plus x and x dot y equal to y dot x. Similarly, we can commutate them, we can reverse the order basically in the commutative. Associative, in the associative we can do the pairing. Like x plus y plus z in a pair, then we can also do the pairing of x plus y plus z. Similarly, in the dot, if we are having x dot yz in a pair, then we can do the pairing of xy dot z. Distributive, as we studied earlier, x plus yz. So, as we have shown earlier that I can directly write it in x plus y dot x plus z, and x, if it is having dot operator over the y plus z, then x will be equally distributed on y and z, and we can write it down xy plus xz. Now, De Morgan's law, it's an important law. What it states, if we are doing negation of any of the literal, then it will get complemented and the operation will also get complemented. For example, if we are having a complement of x dot y, so we are having x complement, dot complement is here OR operator, then there is y complement. And if we are having complement of x plus y, then it is x complement plus will get complemented, it means it will get converted into dot, and then there is y complement. Absorption, as we say, x plus xy will always be our x, and x multiplied by x plus y, it is again our x. Now, unit property. What is unit property say? If we are adding a variable to its complement, then it will be 1, unit 1, and 0 property, what it say? If we are having dot operation of a variable with its complement, then the outcome will be 0 always. Now, what is the minimization of Boolean function? Why we need the minimization first? The minimization is a process in which we simplify the Boolean expression of a given Boolean function. Why this process is important? Because it will simplify, it will give you the reduction of your Boolean function. If your Boolean function is get reduced, then automatically it will gonna reduce the complexity of the associated circuit. It will gonna use, it will give you the lesser number of the literals as well. It will automatically reduce the overall cost. What cost? Hardware cost. Why? Because the number of the gates will get reduced. If the number of the logic circuit gates will get reduced, then the circuit cost which we need to form is automatically get reduced, as well as its complexity also. That's why the minimization of Boolean function is required. And remember one thing, whenever we are doing minimization, it means whatever the outcome we will get, it will be the same as we are having the given expression. It doesn't mean that the minimization will gonna reduce the outcome. The outcome will gonna remain the same, but the number of the literals will get reduced, the number of the logic gates will get reduced, and overall circuit cost will get reduced, and its complexities also will help us because it get reduced and it will simplify the structure, right? So, it is very important, very helpful in circuit constructions basically. The simplification of algebraic functions. In the simplification, first minimization we can do by simply using the Boolean identities which we have studied. For example, we are having one problem here. We need to simplify the Boolean expression. For example, a function is given over the three variables like x, y, a, b and c, that is a bar b plus b c bar plus bc plus a, b bar and c bar. We need to simplify it. Now, how we will simplify it? For example, our given expression is here. Now, what we need to do? We need to do the pairing, because idempotent would say a plus a is a, right? So, here in the bc bar, I can write it down bc plus bc bar. Again, a plus a, I can write it down easily. So, here I am writing bc bar plus bc bar, right? So, if I am writing this, so why I am writing this? Because I will do the pairing here. How I am doing the pairing here? Like one bc bar I am taking with the bc variable, one bc bar I am taking with the last variable. And here, why I am taking this? Because I will take it out something common from these variables. I will take it out b common. In the inner, what will left? C plus c bar. Similarly, in the last one, if I am taking c bar, it will be b plus ab bar, right? And we know with the previous axiom, as we say here, see here, here we can see easily that the variable with its complement is always 1, right? Because it's a unit property. So, here if we will apply c plus c bar with the unit property, we simply write it 1, then c bar inner bracket b plus a. Now, what we need to simplify, like we need to apply the absorption as well, because we know a plus ab bar, we write it down a by taking common, right? So, here it is simply says by using the absorption law, it simply says like a bar b plus c bar b plus a. Now, continuing with that expression, what it do basically here, b is taken common from the first two variable, inner what left, a bar plus 1, previously we are having Previously what we are having C bar with the bracket B plus A. Similarly we have written here. Now 1 plus A bar, if we know that if the 1 is added to any of the variable, then the outcome will be 1. So we will put it here simply. We are having B. Now previous last one, we will simply write it down as it is. We are writing down. Now if we will open this, because C is equally distributed over B plus A. If we will open this, if we will simplify this, this is B C bar plus A C bar. Now again if I am taking B as a common, now inner variable will having 1 plus C bar, and we know with the unit property 1 plus C bar is 1 here, right? So the outcome of this expression when we minimize this, it is B plus AC bar. Now see here, there are 3 variables. We know that simplify structure, what it say, a variable B with the OR operator with the A and C bar AND operator, right? But earlier what we have, we are having this much number of the expression. The outcome will be the same if we will identify with the truth table. So it will reduce our circuit cost as well as it will reduce our complexity as well. That's why we require the simplification. In the examination, simplification always come either by using the laws or by using the K-map. Now again we will see a next property. Let's say there is minimizing the Boolean expression using Boolean identity. It is mentioned here, we need to minimize it by using the Boolean identities only, not using the K-map. So the expression is given, like function is defined over the 3 variable A, B and C, and the given expression is A plus B, A dot C. Now if I will apply the distributive property, if I will open this, so A will get distributed over A plus C, plus B is equally get distributed over A plus C. We will open this. After opening this, A dot A with the idempotent, I can write it down A dot C as it is, B dot A as it is, B dot C as it is. From the first two, if we will take an A common, what will left inside? That is 1 plus C. And we know if 1 plus C, 1 is added to any of the variable, then it will be 1. So what we have written here in the lower part, A as it is, BA, then BC. Then again from the next 2 variable, we can take an A common. Right? If you have taken A common, then what left? 1 plus B, or you can take B common internally, then it will left A plus C, vice versa, both are possible, right? So the final expression what is left here, that is A plus BC. That is a minimized expression by using the laws. See here, the earlier it was given A plus B dot A plus C. Now what is the final outcome? That is just A plus BC. So the number of the gates will get reduced automatically, because in this one we are required 2 OR gate, we are required 1 AND gate here, right? But here 1 OR with the 1 AND we are required here, right? So in this way the minimization will be done. Now let's proceed with the next terminology, that is minterm and maxterm. Why we are studying minterm and maxterm? Because sometime in the K-map it is given in that expression form, and if you will not able to understand, how will we solve it using K-map, right? So these are the 2 ways in which the Boolean function can be put, right? Minterm and the maxterm. For the minterm and maxterm, first we know what are the literals. Literals basically specifies the Boolean variable including its complement as well. For example, if we are having a variable B with its complement, like B negation will be written like this, either will be the B hyphen, right? Now what are these minterms? Minterms are basically the product of all the literals either with the complement or without the complement. That are our minterm. In the maxterm, opposite we can say, the sum of all the literal with the complement or without the complement. See here, the minterm of the Boolean variable A and B. If you are having just 2 variable A and B, then what are the minterm, possible minterm? What can be the possible minterm? Like A dot B, because what we say in the minterm, it is the product of the literals. How many literals we have? A and B. So the product of the literal will be possibly A dot B. And what we say, a literal is signifies a variable including their complement. So the possible combination is AB, A bar B, A bar B, right? So if we are applying the dot operator, what possible minterms we can have? A dot B, A dot B bar, A bar dot B. The complement variable A bar and B bar can also be written as A dash and B dash. How above there is a little bit hyphen, right? So the possible minterm we can write it down A dot B bar, A bar dot B. Now see here, by the minterm from the values, how we will calculate basically. For example, if the variable value is 1, so we will simply take the variable without its complement, means it will be written like x, y or z. If the variable value is 0, then we will take its complement. In a example, let us assume we have three variables a, b, c having the value, a value is 1, b is having the value 0, c is having the value again 0. Now we will take the complement of the variable b and c because they are having the value 0, and what we say, if the variable value is 0, we will take its complement because these are the values which are having 0, and we will take 1 as it is without complement because its value is 1. So what will be the possible minterm? The possible minterm will be a dot b bar dot c bar. And why we write dot here? Because it's a minterm. And what we say in the minterm? It's a product of all literals. Right, here the literals are given in this way. So the product of the literal is a dot b bar dot c bar. Now consider this example, the minterm. If we need to calculate the minterm, a b bar is given to you, right? Why we are writing? We are basically writing it because we need to calculate it shorthand form. Now what is the shorthand form basically? For the shorthand form, what we need to calculate, right? Here for example, a is 1, b bar, it means b is 0. So the possible minterm is having the value 1, 0, right? This is a binary value 1, 0. We need to calculate its decimal value. If we will need to calculate its decimal value, so the shorthand form will be 4, 2, 1 we are having. For 2 it's 1, for 0 it's 0. So 2 plus 0, its value will be 2, right? So the possible shorthand minterm form will be small m2. For the max term we use capital M. For the minterm we use small m. So sometimes it is also written like m2 plus m4 plus m5. So what are the small m? Small m is minterm. Minterm means the product of the literals is given here, right? 2 here means the decimal value. So for the binary we need to calculate the decimal equivalent also, right? Now we need to calculate the minterm of a, b bar, c bar as well here. For example, a means 1, b bar means 0, c bar means 0. This is the binary value. So what we need to calculate? We need to calculate its possible decimal value. So as I told to you, in the binary to decimal conversion, if you will do, you can easily write it down 4, 2, 1 above 8, 16, 32 in this way, right? So 4, 2, 1, it means below 4 there is 1, below 2 there is 0, below 1 there is 0, right? So basically 4 is having 1 value, 2 is having 0, 1 is having 0. It means the possible decimal value will be the 4. So the shorthand notation form for this given minterm is small m with the subscript 4, right? Now, similarly, there are the max term also. As I says, minterms are the product of all the literals. So the max term is the sum of all the literals, either with the complements or without the complement. For example, if we are having the Boolean variable a and b, then the max term will be a plus b bar, a bar plus b. So the possible combinations will be, if we know that the complement variables are a bar and b bar, right? So the above max term can be also be written like a plus b dash, a dash plus b. The negation can also be written with the tilde symbol. It can also be written with the dash symbol. We can use any of the notation, right? So it says max term from the values. For example, what's from the value? It says basically like if the variable is 1, then we will simply take the variable without complement. If the variable value is 0, then we will take the complement of the variable. For example, we are having the three variable a, b, c having the value, again previous example, having the value a is having the value 1, b is having the value 0, c is having the value 0. Now, if we need to write it down in max term, so how we will write it down? A is having the value 1, it means variable taken as it is a. B is having the value 0, it means we need to do the negation of it, right? And C is 0, we need to do the negation of it, and it is a sum of the literal. So A plus B bar plus C bar. So this is the max term. So today we have covered Boolean function, axioms, its identities, min term and max term, right? In the next lecture, we will definitely going to cover the simplification using K-map. That's why we have studied this part. This part will be definitely covered later on. Thank you very much.